Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning into this video in which we'll look at using graphs to solve exponential equations. So let's say we have this equation here. Let's try to solve it as we've done previously by getting x by itself. So we'd start by adding 3 to both sides. So we'd get 2 to the power of x plus 7 is equal to 5. Now, what we were doing in the previous video, we were writing this as a power of 2 and then equating the powers. But we can't do that here. There's no whole number power of 2 that is equal to 5. The powers of 2 are 1, 2, 4, 8, definitely not 5. It's not obvious at all what you raise 2 to the power of to get 5. So we need another method for things like this. So we could use a graphical method. So what we could do is we could graph these two functions. We could graph y equals 2 to the power of x plus 7 and y equals 5. If we put them on our graphics calculator, we can then calculate the point of intersection. So if I graph both of these on my graphics calculator, I get something that looks like this. Y equals 5, perfectly horizontal line, and y equals 2 to the power of x plus 7. It's an exponential, getting fast very quickly. So what we're looking for here is the x value of the point of intersection. So the point of intersection is here. So if we go down, it's somewhere between -4 and -5. So we don't just want to guess it or use trial and error. That will take too long. Our graphics calculator can actually calculate this point of intersection pretty accurately. So to do that, you go to the calc function and you go down to intersect. Now for the graphics calculator, it'll ask you to go left bound and right bound. What all that means is when it says left bound, you pick a point that is just left of the point of intersection and a point that's just right of the point of intersection, and then it will say guess, you press enter, and it will give you the point of intersection. So the actual point of intersection here is about -4.67815. So this is the x value that we require. This x value -4.6781 solves this equation here. It also solves this equation here. So that's how we can use graphical methods to solve this equation. So in fact, you didn't actually have to go from this step to this step and show the working out. I just wanted to show you why there's a problem here, why we can't do what we did last time. You could have just put y equals this as one function, y equals 2 as the other, and found their point of intersection. You would have got the same x value, which is what we want. So just in case some people are wondering, and some people know, you can actually use logs to solve this equation. So you might even find that quicker than the graphical method. So what we have here, if we got down to here, we don't know what I raised 2 to the power of to get 5. What we can do is take the log of both sides. So what we would have is the power, which is x plus 7, is equal to log of answer over log of base. So we can just put that straight in our calculator, log of 5 over log of 2. The answer you get is something like 2.3219, and then you would just subtract 7 from that. So the exact answer in your calculator is log 5 over log 2 minus 7, which is, you guessed it, about -4.6781. So you don't need to know logs. I was just showing this because some people have learned logs and might find it easier to do it this way than graphically. All right, thank you so much for tuning into this video. This has been the luckiest maths teacher in the world. Have a great day.